Hi guys. Okay, so I'm going to walk you through the lab because you don't have access to these lab activities. I'm going to be working on that in the future. I don't know why they don't grant the lab courses currently the Pearson access, which would make this so much easier. But I'm going to go ahead and just do it, model it, let you see what it's about. That way you can answer your pre-questions and any other questions that come along in quizzes so that you can kind of experience the lab. So most of these first slides I have already put on a Google slideshow for you, and I will be embedding these videos. So the whole point of this is to observe how a particular endocrine hormone, specifically the ones created by the thyroid, play a role in changing the BMR, which is the basal metabolic rate of an individual. And in this case, we're going to be using rats. So this is some background information about metabolism, what's included, what the specific thyroid hormones do, what are the hormones that stimulate the thyroid itself. So this is going to be in that Google slide for you to read through. Then it also talks about how do both of those hormones get stimulated and produced via the hypothalamus. So there's some background information. This information is testable, and you will see that with your pre-lab questions. Okay, again, we're just looking at some terminology. There will be some quote unquote dissections in this little simulation. And so this is describing what's happening. So this is just background information. This is talking about the equipment that's, if you were doing this in real life, these are the pieces of equipment that we're modeling in the lab. Okay, so I'm going to skip through those because you have your pre-lab questions already. So I'm going to push continue. Okay, so if you were doing this yourself, you would just be following these prompts. So this first one says I need to drag this normal rat into the chamber. Okay, I'm going to push next. Then it says select the weight of the rat. So I'm going to weigh the rat, and I push next. Select the clamp on the left tube to close it. This will prevent air from entering the chamber from the outside. So I'm going to close that, and I'm not going to say next every time. I think you can get the point there. Then it says set the timer for 1 minute, then push start to measure. We're measuring the amount of oxygen consumed by the rat in 1 minute in the sealed chamber. Okay, and we're going to watch what happens to the water levels in that chamber. So I'm going up to 1 minute and pushing start. And so again, we're watching the levels change where it was at 10 on both sides. And it is now displacing water because of the oxygen breathing. Okay, so again, we watch those water levels change. I then push next. It says select the T connector knob to connect the syringe. So this is going to be adding a dose of this. And then we're going to turn the clamp back on to where it will let oxygen from the outside enter. Okay. And then it says, observe the difference between the level in the left and right arms of the manometer. Estimate the volume of oxygen that you will need to inject to make the level equal by counting the divisions on both sides. This volume is equivalent to the amount of oxygen that the rat consumed during the minute in the sealed chamber. So we're going to select the plus button to the right of the milliliters of O2 display until we reach the estimated volume. Then we're going to select the inject button. We observe what happens to the fluid in the arms when the volume levels are equalized. The word level will appear and stay on the screen. If you have not injected enough, the word level will not appear. And then we have to increase and inject again. If too much is showing up, then we have to, we will choose the decrease button and inject again. Okay, so they both started at 10. So I'm going to say 1, 2, 3. Let's just start with 3 mils. Let's start with 3 mils of O2. And we're going to inject. And we're going to see what happens. Nope, that was not enough. Okay, so now that I'm a little bit closer and I can see a little bit more of what happens, I know that this is going to be 1, and that's probably going to be 1.8. So let's add another 1.8. Oh, I was going the wrong way. Stop that. So I'd added 3, and so I'm going to go to 4.8. And let's inject and see what that does. Yep, still not enough. So I'm going to go another, let's do 10. Inject. Oh, we missed it by a lot. Oh gosh. Okay, so let's put in 8.2 or 3. Yeah, a little bit of trial and error here. Let's inject and see if we get back to a closer range between the two. Level, yay. Okay, so then we're going to push next. All right, so calculate the oxygen consumption per hour for the rat using the following equation. So we have the milliliters of O2 consumed divided by 1 minute, and we times that by 60. All right, so what we do is we go to that value that we had. So it was 7.1. So 7.1 is then put over 1 minute times 60. So it just should be 7.1 over 60. So it should be 0. Are we rounding 1? Let's do 118 and see if that. Okay, so now we calculate the oxygen consumption to determine the metabolic rate per kilogram of body weight with the following equation. Note that you need to convert the weight data from grams to kilograms. Remember, converting from grams to kilograms, you are shifting. In this particular case, we want it in kilograms, so it's got to shift to the left, which means that it's going to be a smaller value, okay? So if this is in grams, 249 grams, we would shift 1, 2, 3 to the left, which would give us, and you have to kind of think, if kilograms is bigger, then the grams is actually a smaller part of that kilogram. So that weight ends up being 2.249 kilograms, okay? And that's going to be the denominator of the value that we just got, which I think we said was, honestly, I can't even remember now, but we can redo it again. So 7.1 divided by 60, and then we're going to times that by our 0.249 kilograms, and that should give us 0.02, and I'm not really doing a very good job of worrying about significant figures here, so I'm just going to put in and let's submit it and see how we go. So select the palpate thyroid to manually check the size of the thyroid and thus whether a goiter is present. Okay, so we're going to push palpate thyroid. No remarkable findings, so that means that we did not find a goiter. So we're going to record the data and display on the grid. So we're going to record data, so it now displays it. Okay. So we then move to the next. Drag the rat from the chamber back to its cage and select restore beneath palpate thyroid to restore the apparatus. We're going to grab Mr. Normal Rat. We're going to restore the thyroid to the initial state. Then we move to the next. So let's make some predictions about the basal metabolic rate, BMR, of the remaining rats compared with the BMR of the normal rat that we just measured. Okay, so here is our normal values down here. So we should be able to, let's look at this. The thyroidectomized or the TX rat BMR will be the same as the normal rat's BMR. I would assume, let's make some assumptions. We're making predictions. I would assume that if you take a thyroid out, which is the thyroidectomy, ectomy means to remove, then you're probably not going to have the same basal metabolic rate as you would with a normal rat. The hypophysectomy is the pituitary gland. And so that will be the hypox abbreviation. This rat's BMR will be higher than normal rat's BMR. So it's saying if I removed the pituitary gland, which, by the way, stimulates the thyroid gland, it's saying that it would be higher than the normal rat. So I'm going to guess that if I take my pituitary out, I'm probably not going to have a very high rate of BMR because I don't have the pituitary stimulating the thyroid. So I'm not going to choose that one either. The BMR of both remaining rats will be lower than the normal rat's BMR. That sounds pretty good. Let's read the fourth one. You will not be able to measure the BMR of the remaining rats. That's not very logical because we were able to do it on the normal one. So I'm going to choose this third one. Okay. All right, so we're going to drag the TX rat into the chamber, and we're basically going to do the same exact things. We're going to do the weight. We're going to turn on the clamp. We are going to choose a minute, and we're going to push start, and we're going to see what happens to the water. Over that minute, okay? And we will be noticing the water level in a minute. So I'm going to turn that on, and I'm going to push next. And then I'm going to select the clamp over here so that we can get oxygen back into the chamber. Okay, so now we're going to do the inject thing that I'm not really good at. Let's see. So I'm going to say 1, 2, let's start with 3. I'm sorry, it should be going. No, that's right. Let's start with 3. I'm sorry, this is not my favorite part right here. I'm like, click, 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 click. And let's inject and see what happens and see how much we need to move. Okay, so I'm going to say let's do another 2. Okay, let's keep this party rolling. Let's do that. Oh, we're so close. Ta-da! Okay, and then we are going to push next. Okay, so we're doing the same thing with the calculations, which ends up being this value right here, this 6.3. And, when you have 1 times it's anything, it's itself. So you're basically just putting that 6.3 divided by 60. Which is 0.105. Okay, so 0.105. Submit that data. Okay, now that you have calculated the oxygen consumption, we're going to do the BMR. So the same basic thing, but we're doing the difference in weight. So we're taking that 0.105 milliliters of oxygen per hour, and we're going to divide that. It's a little division. We're going to divide that by our weight of this rat was the same, so it's 0.246 because we would move 3 spaces to the left, okay? And that value that we're given is 0.426829 2683. You probably, yeah, okay, so it stops me. You probably wouldn't have an apparatus that could measure that many. Okay, so we're going to palpate the thyroid. No remarkable findings. We're going to record data. Okay, and then we do it again. We start with the third rat. So we're going to restore this. We're going to move this one over. We're going to, there we go. We're going to weigh it. Okay. I'm going to turn the clamp on. We're going to add a minute. Pushing next. Oh, I'm sorry. Start. So we're watching it move. Okay. We're going to turn the T knob. We're going to turn the oxygen back on. And then we're going to do our little injectee thing. So it looks a little less like so I've tried 3 every time. So let's try 3 again and see if we are not on I'm really not good at this. So maybe I should just stick with like 5. Let's do that one. Okay. And then, so we push next. And then we basically are going to do our calculations for the consumption again. So 6.3 divided by 60. Metabolic rates. We're doing that value over its weight, which is 0.245, which gives us 42857142. Okay, that should be plenty. All right, we're going to palpate the thyroid. No remarkable findings. Okay. Now, judging on their rates, categorize the rats accordingly. Oh, I forgot to record data. Poo-poo. Let me backtrack to that previous one so I can, let's see if it's deleted all of my data. Oh, poop. It deleted all my data. Let me pause real quick and let me get that restored. Okay, so I did go back and redo those other values, but what I'd like to notice or to point out here is that even though the BMR is going to be lower, the BMR for the regular rat, which disappeared, sorry, was about 1700. No mass results from the loss of the thyroid or the loss of the pituitary, the anterior pituitary. So again, you have to kind of keep in mind that a goiter would result if you had too much. And that's kind of the idea here. But in our next series of reactions, we'll look at that. Okay, thanks.